Hey guys, welcome to Algebra 2. This is our first real lesson, and it's what I'm going to call Chapter 0. Okay, as in, we're not really into what is part of the textbook, but it's very important to give us some linear review, refresh our brains, think about what it really means to graph. So I have this example problem here, but I'll get into that later. What I want to start with is some reminders of what does it actually mean to be a graph. A graph is a visual representation of information, specifically, in its simplest form, all these different locations, where everything that's happening here is a representation of a function and its solutions. So what that means is each one of these points helps me solve some type of problem. That there's some type of y equals something x, some type of equation where I can plug in both a 5 for my y value and a 2 for my x value. And I could do something like plug in a 1 for my y value and a 0 for my x value. And whatever's going on in the rest of my equation will help make this true. So this is the equation. And the reason it creates a graph is because each one of these points will successfully, when I plug that in for x and y, I'll be able to go, yep, it works. Let's talk about what it means to be a function. We'll talk about function notation in a little bit, okay? Function is a relation where everything that's in the domain, all the x values, is associated with just one y value. That doesn't mean you're not allowed to have repeats. Like we look here, if I plug in a 2, I get 3, and if I plug in a 3, I get 3. That's fine. The way you're not allowed to have repeats is having something that you plug in, like 4, result in 2 different answers. As long as when you plug something in, you only get one result. That result's allowed to repeat, but when you plug something in, you only get one result. Domain and range, we just sort of touched on. Domain is all the possible things you could plug in, all the x values. So when we're dealing with linear functions, the domain is always like everything, because I could go all the way back to negative infinity or positive infinity. And the range, same thing. I can go all the way up, I go all the way down. In this class, in Algebra 2, we'll talk about limits on these things, which will be pretty fun. Slope is another thing that we're reviewing from Algebra 1 that we've hopefully seen before. It's just your change in y over your change in x. Basically, how much do you go up compared to how much do we go over? So in this case, I go up 1 every time I go over 3. So that makes my slope, which we will annotate with the letter m, as being 1 over 3. I go up 1 over 3, up 1 over 3, between every single point. One thing we did not touch on was x-intercepts and y-intercepts. Okay? To be on the x-axis, to be on this line, you must have a y of 0, right? Because you're not above or below. So basically saying, well, what number would I have to plug in for x so that I wind up somewhere on this line? Similar thing for the y-intercept. If I'm not left or right of it, if I'm on this line, I must have an x of 0. So what y value results in an x of 0? Or if I plug in an x of 0, where do I wind up on this line? What's the result? I'll touch briefly now on function notation, okay? This is something that my students don't necessarily love, and I think that's fine because you spend so much time with this. This is what you're introduced to, y equals 2x plus 3. It's a linear equation. Awesome, okay? I don't want you to overcomplicate what function notation means, you guys, okay? Because function notation, f of x and y, they mean the same thing, okay? They're outputs. They're the results. In y equals 2x plus 3, I plug something into x, okay? And the result is the y. If you think in a scientific perspective in terms of independent and dependent variables. F of x, the function of x, is also still just the output because it's saying, okay, what number, and when you plug a number in here, what is the number that you get out? So what I like sort of showing is that, like, if I ask you, hey, what is the function of 2? all that's really telling you is, hey, I know that it's possible for you to plug in a 2. And when you do, what's the result of the function? Right? This is the function. I want to know what's the result of the function. Okay, well, I'd say I just got to plug this 2 into the x, right? If we're replacing every x with a 2, okay, 2 times 2 is 4, plus 3 is 7. So what is the result of f of 2? It's 7. If I was thinking about this in terms of a graph, this point would be over here, and I'd call it 2, comma, 7. No differently than I would have called this point 2, 7 if I used this instead of function notation. So I understand that function notation is maybe a little new to you. You don't love it, but it means a lot of the same stuff. It means a lot of the same stuff. So now let's spend some time talking about the forms. This is something, again, that's review. We're not going to spend too much time talking about slope-intercept form, or sorry, point-slope form, which is this one right here. But we are going to talk about slope-intercept, which is probably what you're used to seeing in standard form. I know to say it's kind of funny. A lot of you guys probably think that this is standard form because that's how you see so much of it, right? Talking about slope-intercept, okay? M, like we talked about, is the letter, the variable that we use to represent slope. So if you think about it, y, the result, is always equal to taking the slope, the rate of change, multiplying it by whatever your input was, and then adding whatever that intercept, that y-intercept is. Why am I adding the y-intercept? Well, if we think about it, the y-intercept occurs somewhere on this point, or on this line, the y-axis, right? That's what happens. Well, how could I wind up there unless I had an x value of 0? And we know that if I'm doing, okay, m times 0, so whatever the slope is, plus b. Well, whatever the slope is times 0 becomes 0 because it just, there's nothing there. It becomes nothing. So what is the y? It's got to be whatever this b value is. So I always say, like, there it is right here, 0, comma, b. That point will always be a part in slope-intercept form. Why is standard form helpful, you guys? Well, with standard form, I think it's really good to identify our intercepts. I think that's what makes it really, really helpful. It doesn't necessarily show us our slope because we can see x and y are sort of on the same side of the equation. But what makes something like this helpful is I can ask myself really quickly, what happens when x is 0? And what happens when y is 0? And that'll give me 2 really quick and easy points right off the bat. And when I have 2 easy points, when I'm graphing a straight line, that's kind of all I need. I'm done at that point. So if I look at standard form like this, okay, if x was 0, if this was just 0, what would y have to be? 4. That's the only way that would work, right? So I know that I have a point at 0, 4. And then I'm going to do the same thing where I ask myself this hypothetical question, where this time I'll say, what if the y is 0? 2 times 0 is 0. So what if I had nothing there? What does x have to be? It has to be 8. 8, 0. And now I have 2 points, and I can make a graph. So now what? Let's just practice some graphing. That's really how we're going to start this class. My suggestion, input-output table. So I'm going to go all the way back to the warm-up at the beginning right here. Okay. So what do I mean by a table? I mean, create a list of inputs and outputs. And I typically will do stuff like this. What happens if I do -1, 0, 1, 2? Those are always good points to test. So what happens if I plug in a -1? All right, I got to go up here and plug in a -1. 2 times -1 is -2. And -2 plus 1 is -1. So why don't I go ahead and mark that point? If I plug in 0, 2 times 0 is 0, plus 1 is 1. So 0, 1. Right? Now that's what I'm talking about when I say that is a special point. What's my y-intercept? Okay. 0, we already did that. 0, 1. If I plug in a 1, 2 times 1 is 2. Plus 1 is 3. 2 times 2 is 4. Plus 1 is 5. So I get all these points. Okay. 1, 3. And 2, 5. And just like that, I got a line. Awesome. That's what our practice work's going to look like today. This is review, but it's good stuff. And that's classic, a bell right in the middle of me trying to end my video. Fantastic. First lesson of the year. That's a wrap, you guys. And we'll be back with some how to write our own equations tomorrow.